numbers and I. Trace the following. The square root of -1 is equal to I, the imaginary number. Take it another way, if you square both sides, -1 is equal to I squared. You get this, and you can brace this. It's pretty, you can pretty much work through just about anything we're going to be doing today. So, if Mr. Kuhne were to give you the following. Square root of -4, I want you to simplify that, or if I said the square root of -18. Square root of -4, we could break up into the following. Square root of 4 times square root of -1. Square root of 4 is what, everybody? 2. Square root of -1 is?
I.
2I. Square root of -18. Now we can break this up into the following. Square root of 9 times the square root of -1 times the square root of 2. Square root of 9 is 3. Square root of -1 is I. Square root of 2 is just square root of 2. We normally put it, so if there's a negative in front of square root sign, we normally just bring it out here as I. If Mr. Kuhne were to give you the following. 2I times -5I. Any guesses what that's going to be? Sir?
-10I squared.
Negative. So we got 2 times 5 is -10. I times I is I squared. But we're not done. Because what is I squared?
Square root of -1. Or just -1.
It's just -1. So this is 10, -10 times -1. So we get the answer of 10. This one's pretty simple right here. If I had 6 minus 9I and 3 plus 4I. Any number written like this, a plus bi, that's called a complex number. It's called a complex number. So we're adding 2 complex numbers here. Let your intuition take you here. This is not as hard as it seems. What do you think this is going to be? -9i plus 4i? -5i. So we're treating the I here just like a variable. Or just like a square root. Because that's what it is. This one will be a little bit tougher. You have to multiply 3 plus 2i times -4 minus 5i. Start off just like you normally would. Go ahead and distribute. check that out what you have so far. So far, so good. We can combine these, right? So negative 12 minus 23i minus 10i squared. But are we done? No, of course not. Because, Jed, what is I squared?
I squared would be
Negative 1. Negative 12 minus 23i minus 10 times negative 1. So that's really going to be positive 10. Negative 12 minus 23i plus 10, which is going to give us the final answer of negative 2 minus 23i. And we always put the I at the end. If we're doing a complex number, we always put the I at the end. I'm going to make a chart up here. We'll just kind of fill this in here. I squared, I to the third, I to the fourth, I to the fifth, I to the sixth. You'll notice a pattern, and then I want to know what is I to the 43rd. Take about a minute here, maybe a minute and a half, and go ahead and fill this in. What is, I is, no, just I. What is I squared? I to the third, I to the fourth, I to the fifth, I to the sixth. What's I to the 43rd? We'll go ahead and pause the video too. Here we go. All right, what is I squared? What is I cubed? Well, I cubed is I squared times I, right? So it's negative 1 times I, or just negative I. What's I to the fourth? Nobody? I squared times I squared, which is?
1.
Negative 1 times negative 1, which is?
1.
1. What is I to the fifth? Well, let's see here. I to the fifth would be I to the fourth times I, right? So I to the fifth is really just 1 times I, which is I.
Wow.
What's I to the sixth? I to the fourth times I squared. What's I to the fourth? 1. I squared is negative 1, so it's negative 1. Are you seeing a pattern here?
Yep.
After every 4, it starts over, right? So I to the 43rd. I to the 43rd, it started over 10 times, right? So really, it's basically just the same as I to the third, isn't it? It's I to the 40th, but those kept starting over, times I to the third. And so that's just 1 times I to the third. I to the third, though, is 1 times I squared times I. 1 times negative 1 times I, so it's just negative I. Now, is this something that normally comes up in the math and science world? No. This is checking this. This is just kind of brain teaser stuff to see if you know how to apply the patterns. This is as far as I know, it does not come up in the big science world. All right. Let's see here. 4 minus 3i times 4 plus 3i. You're going to notice something super cool here. Go ahead and distribute that. Notice how this is really just, this is giving us the difference of squares, isn't it? The middle term cancels out. How lovely is that? We get 16 minus 9i squared. But we're not going to use I squared, are we? What is it?
1.
16 minus 9 times negative 1. So really it's 16 plus 9, isn't it? So the answer is 25. 25 is the answer. We're going to use this property here in just a moment. You know how they say you're not allowed to have square roots on the bottom? Okay, and I just square root of negative 1. We're going to be dealing with that as well. First, though, a slightly different example. No, we'll go ahead and do that one after all. I have 12i over 1 minus 2i. So some people say you can't have square roots on the bottom. Now you get to a certain level of math, yeah, fine. Square roots on the bottom, not a big deal. Just like your middle school teacher told you, you can't have an improper fraction. But we know that's a lie, right? Mostly we're just trying to figure out how to move things around into forms that fit us for our purposes. Sometimes 75% is better, sometimes 3/4 is better, right? Sometimes 0.25 is better. I'm sorry, 0.75 is better for us. So we just want to be able to move things around into different ways of looking at things. Sometimes 6/8 is better. So we're really just trying to get this into a form that's easier for us to work with. Normally complex numbers are written as a plus bi. This is not an a plus bi form, is it? We have a square root on the bottom, we got an I on the bottom, and we got to get rid of that. So we're going to have to multiply this, the top and bottom, by something, but it's got to be the same number. We're going to use the identity property, multiply it by the same number, top and bottom. Well, we want to get rid of the I on the bottom. Look at what we just did. When we multiplied by 4 plus 3i, did we have any i's in the answer? No. So what do you want to multiply the bottom over here by? Not I. Not 2i. You're close.
Negative 2i?
Nope. Look at this one. It's 4 minus 3i. If I multiply just the bottom by I, this is going to be 1i minus 2i squared, right? Then get rid of the i's. Well, multiplied by 2i. I'm going to have 2i minus 4i squared. That didn't get rid of it.
Plus 2i.
There we go. There's my man. 1 plus 2i. This is 4 minus 3i. If I take it times 4 plus 3i, you got rid of the i's. 1 plus 2i. This is called a conjugate. That's called the conjugate. Now, if we multiply the bottom by 1 plus 2i, guess what we have to do? We've got to multiply the top by 1 plus 2i. And we'll distribute our little hearts out. 12i times 1, 12i times 2i is going to give you 24i squared. And on the bottom, 1 times 1 is 1. 1 times plus 2i. 1 times. And we have negative 2i times 1. Then negative 2i times 2i is minus 4i squared. Well, those middle terms cancel out for us, didn't they? That's super fantastic. And I squared is really negative 1. So I'm going to really have 1 minus 4 times negative 1, so the bottom's really just 1 plus 4, isn't it? On the top, I squared, well, we know that's really negative 1. So it's going to be 12i minus 24. So if we simplify a little more, it's going to be 12i minus 24 over 5. Now, normally we like to think that's okay, but they want it written as a complex number. So we got to stick the i's on the end and have the two numbers separate. So we're just going to switch this around to negative 24 plus 12i over 5, which gets switched to negative 24 over 5 plus 12i over 5, or 12/5 I. So the steps here are basically the following. Multiply by conjugate. Simplify numerator and denominator. And then change into complex number standard form.